All right, welcome back to the new unit here. We are on Unit 6, and this is the first lesson for Unit 6. In this unit, we're going to be looking at the equation of lines, okay? There are different forms of an equation of a line, and we're going to be looking at different forms. But first of all, we are going to be looking at the slope of a line, okay? So slope is actually quite important when we talk about a line, okay? It's one of the most important characteristics of a line, okay? So what's a slope? Well, slope is essentially how steep a line is, okay? So the bigger slope, the steeper the line is, okay? The smaller the slope, the less steep the line is, okay? So slope tells us how steep a line is. Okay, so we usually use the letter M, okay, M to denote what a slope is, to quantify it. And to calculate the slope, we say that the equation of a slope, okay, so slope is equal to rise over run. Now you might ask, well, okay, so cool, that's the equation, or that's the meaning of it. So what's the rise and what is the run? Well, rise is how much change there is vertically, okay? Or we can usually just say that this is the change in y values, okay? How much change, so how much higher it goes up to or how much lower it goes down to, right? So how much change there is vertically. In other words, it's the change in y values. So you could probably guess that the run then would be how much change there is horizontally. Okay, so this is the change in the x values. Okay, change in x values. Okay, so one, when we talk about rise, we're talking about how much it goes up or goes down. And for run, we want to see how much it moves sideways. Okay, so usually we talk from left to right because that's how we graph, we graph lines or any kind of graph on the grid, on the graph paper. We usually graph from left to right. Okay, so when we talk about run, we usually talk about how much it changed from left to right. It doesn't have to be though, okay? Okay, so let's look at some examples here. We have 3 lines here. You can see there's first line, second line, and third line, and that they have 3 different slopes, okay? You can see each graph, it shows you the rise and the run. So let's figure out what the rise and the run is for each of those 3 graphs. Okay, so for the first one, the rise, we are, again, because usually when we graph from left to right, so we're going to count from here, this point, to that point, okay? So if we counting from left to right, then this is actually going up, right? So the rise is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the run is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as well. So the slope, it says here, slope is equal to rise over run. So here we know the rise is 10, and the run is also 10. So the slope is 10 out of 10, which we can be simplified to just 1. Okay, so that's the slope for the first line. For the second line, similarly, we have the rise here. Again, if we count from left to right, so from here to here. Now, you don't always have to draw the triangle, right? So what I'm going to show you is I'm going to count from this point to that point without the guide of the rise and the run line here. Okay, so I'm going to count from here. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the rise is 10, and then 1, 2, 3, 4, 5. So essentially, you're making your own triangle. Okay, so the slope is rise over run, so 10 out of 5, which is going to be 2. Okay, lastly, if we do the same thing from left to right, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry, that's the run, my bad. And the rise is 1, 2, 3, 4, 5. Okay, so rise over run is going to be 5 out of 10, which is 1/2. Okay, so part B here says, which slope is the steepest? Well, the steepest line that you can see is slope B. B is the steepest, and you can see the value of the slope is also the biggest, right? Which slope is the least steep? You can see from the graph that slope C is the least steep, and you can see the value of the slope is the smallest. Okay, so again, this just verifies that what I just said, the bigger the slope, the steeper the line is, okay? And the smaller the slope, then, well, the less steep, okay, the line is. Now, we don't always have positive slopes. We could also have negative slope, okay? So what does that look like? Well, let's look at the first line here first. Let's count the rise and the run so we can find the slope. Again, so we usually go from left to right. So I'm going to count from this point to that point. So the rise is 1, 2, 3, 4, 5, 6. Run is 1, 2, 3, 4. So the slope is 6 out of 4 or 3 out of 2. Okay, so this one, you can see the slope is positive. Now you can see in part B, you can probably guess it, this would have a negative slope because if you look from left to right, this is going downwards, right? It's going this way. Again, if you graph from left to right, it's actually going downwards. Okay, so again, I'm going to count from left to right. So from this point, I'm going to go 1, 2, 3, 4, 5, 6 units down. Okay, because we're going downwards, the rise is actually negative 6. Okay, so again, because we're going downwards, so the rise is actually negative. For the run, we have 1, 2, 3, 4, 5. Okay, so the slope is negative 6 out of 5. Now you might ask, how come the rise is negative but not the run? Okay, so if you always just count from left to right, then the run is always positive. Okay, only if you're counting backwards from right to left, then your run will be negative. Okay, so for example, if you count the second one here from this point to that point instead, you would go 1, 2, 3, 4, 5, 6. Right, actually 6 up. And then you're going from right to left now. So you go 1, 2, 3, 4, 5. So then run will be negative. So you end up with 6 over negative 5. And remember, negative 6 over 5, 6 over negative 5, they have the same value. Okay, so it doesn't matter how you count it, really. But usually, by convention, we just count from left to right, okay, because that's how we graph it. But it doesn't really matter, though, okay? Okay, so there's A and B. Now let's continue to look at C and D before we do some practice. Okay, so this one is kind of interesting. It's a flat line. Okay, before you actually count, think about the steepness of a flat line. What do you think it is? Interesting. Okay, so keep that in mind. Okay, now let's count. So from this point to that point, well, what's the rise? Well, we're not going up or going down, so the rise is 0. What's the run? Well, we're going 1, 2, 3, 4, 5 units to the right. So the slope is 0 out of 5, which means the slope is 0. That makes sense, right? Because it's not going up, nor it's going down, so it's flat. Then therefore the slope is 0, right? The steepness of this line is, it's 0, right? There is not a slope, okay? Okay. Part D, this is interesting. This is a vertical line, okay? So what's the rise? Well, it's kind of hard to tell if it's going up or going down because there's no left or right point because it's on really the same x value. I'm just going to say it's going up, okay? So 1, 2, 3, 4, 5, 6. Then we're going to go 6 up. You can say 6 down. It doesn't really matter. Okay, the run, well, in this case, the run is 0 because we're not moving to the left or not moving to the right. So the slope is 6 out of 0. Now, if you remember, we cannot divide it by 0, so we say that this slope is undefined. Okay, this is too steep. It's not really, again, it's not like a ramp anymore. This is a vertical change. This is a vertical drop or, just ascending at 90-degree angle. Okay, so this is not it's not at a slope. Okay, so the slope is undefined. It's too steep. Essentially, that's what it is. Okay, so there are 2 questions for you to practice. Give it a try and see what you get, okay? Okay, so let's count. That's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So the slope is 7 out of 7, which is 1, okay? The second one here, we have 1, 2, 3, 4, going 4 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 to the right, so the slope is negative 4 out of 9. Okay, hopefully that's what you got. Okay, and hopefully this is not too difficult for you. Okay, so now we're gonna go kind of backwards. We were given a line and then we are finding the slope. And now we are gonna be given the slope and draw the line, okay? So here is the slope, right? Slope is rise over run, recall. and here is the fraction, right? It's 7 out of 5. Okay, oh, you might ask, what if the slope given to us is in a decimal, right? Well, then you got to convert into a fraction, okay? So make sure you are writing the slope in a fraction so then we can find the rise and the run. Okay, so the rise in this case is 7 and the run is 5. Okay, so here you can see on this grid, there's a point that's given to us, starting point of C. So we're going to start from this point and we're going to draw this line now, okay? We're going to find the next point, right? Given that the rise is 7, we're going to go 7 up. 1, 2, 3, 4, 5, 6, 7. Okay, we're going up because, again, the rise is positive. And run is positive 5, so we're going to go to the right. So 1, 2, 3, 4, 5. And there is our second point. So we're starting from this point, and then we're going to connect this point with that point, and there is our line segment right there. Okay, and here we go. Part B. Now, the slope in this case is negative 3 out of 8. Now, you might ask again, where is the negative sign? Do I put it for the rise or do I put it for the run? Again, it turns out it doesn't matter, okay, as long as you keep in mind that if the rise is negative, then you're going down. If the run is negative, then you're going to the left instead of going to the right. Again, by convention, usually we go from left to right. So I'm going to keep the run positive and by making the rise negative. Okay, you can do it the other way around, but it won't really work because we don't have that much space on the left-hand side of this point D right here. Okay, so the rise is negative 3, so I'm just going to go from here, 1, 2, 3 down, and run is 8, so I'm going to go 8 units to the right. So because we start from 0, I know that we're going to end up with an 8. Okay, you can just count, right? Because we start at the x value of 0. If the run is 8, that means I'm going to end up with the x coordinate of 8. Okay, so there's my first point. There's my second point. Again, if you're not sure, you can always count, right? 1, 2, 3, 4, 5, 6, 7, 8. There you go. You can connect the points, and there is your line segment. Okay, so similarly, there are 2 for you to try. Okay, good luck. Okay, so the rise is 4, run is 9. So start from 1. We know if we go 4 up, we're going to end up with a 5. And I start with x value of 0. If the run is 9, I know I'm going to end up right here. So there's my final point. Final destination right there. Okay, you can, again, always just count. Okay, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, same thing. Rise is negative 6. Run is 5. So from here, I'm going to go 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5 right here. There is my line segment. Okay. Okay. Now, what if? Okay. So then, so first of all, we have the graph, and we were finding the slope, and then we had the slope, and we were graphing the line. And now, what if we are not given the graph, and then try to find the slope? Okay, so it turns out that, recall, slope is just rise over run, which means it's the change in y values divided by change in x values. So the change in y values is, there you go, y2 minus y1, right? This, if you've taken science, this is the final minus initial. Essentially, you can think of it that way. That's the final minus initial, right? Or that's just the change in the y values, and this will be the change in x values. Now, does it matter if we do y2 minus y1 or y1 minus y2? No, it does not matter. However, you need to keep it consistent, okay? So if you start with y1, then you must start with x1, okay? Then you can't, so what I'm trying to say is you cannot do this. You can, I'm going to do y2 minus y1, and then I'm going to go x1 minus x2, okay? Then that doesn't work, okay? If you're going to start with y1, then you also need to start with x1. If you're going to start with y2, then you have to start with x2. So that's the formula for finding the slope, okay, with just given points, right? You can see here, they are just points, okay? We're not given the graph, okay? I mean, sure, there's a graph here, but let's look at this example here. It says, determine the slope of the line that passes through the points -5, -3, and 2, and 1. Obviously, you can plot the points and count, and I mean, by all means, that's not wrong. But we just want a little bit more efficient way of doing this. Okay, so we can find the slope of AB. I'm just going to call this M. and subscript AB. Okay, the slope of AB. This, recall, is y2 minus y1 over x2 minus x1. So here is x1, y1. Here is x2, y2, right? That's the first point. That's the second point. And again, you can label A as x1, y1, or you can, if you want to, label A as x2, y2, and B as x1, y1. Okay, it doesn't really matter, okay? Again, as long as you keep it consistent, that's all it matters. Okay, so y2 is 1 minus y1, which is -3, so be careful. It's 1 minus -3. And for the x's, we have x2 as 2, and x1 is -5, so 2 minus -5. So now this is 1 minus -3, so remember minus -3 means 1 plus 3. So that's a 4, and 2 minus -5 is 2 plus 5, which is 7. So there you go, that's the slope, 4 out of 7. Okay, 4 out of 7. I mean, you can see this, right? From here to here, you're increasing by 4. From here to here, you're increasing by 7. There you go. Change in y divided by change in x, 4 out of 7. Okay, so there are 2 questions for you to try. Good luck. I'll leave the formula here so you can see. Okay, so the slope of mn is going to be 1 minus 3, -5 minus 2, which is going to be -2 over -7, which then is positive 2 over 7. Okay, yeah, that's right. Whereas the m for PQ, y2 is 4, y1 is 1, x2 is 7, x1 is -3, so this is going to be 3 out of 10. 7 minus -3 is 3, 7 plus 3, which is 10. Okay, hopefully that's not too bad. Last thing we need to look at is the rate of change. Okay, so we saw this last unit, right? We briefly talked about it. Rate of change is actually just the slope of the line segment, okay? So rate of change, slope, they are really talking about the same thing, okay? Rate of change is the change in dependent variable divided by the change in independent variable. Remember, that's what we're talking about. And the dependent variable, remember, is the y value, right? And independent variable is the x. And therefore, change in dependent variable is really just talking about the change in y. Change in the independent variable is then just the change in x, which is exactly what we talk about here, right? Slope is change in y divided by change in x. Okay, and that's why it's the slope. Okay, so let's take a look here. It says David recorded the distance he had traveled at certain times since he began his cycling trip from school to downtown. He plotted these data on the grid. What is the slope of the line through these points? Okay, so we could technically join the points together, right? Because this is continuous variable. That's also a continuous variable. So we can actually join the points together like that. Not a problem. Okay. Given that he continues this pattern. Okay. All right. So we have the coordinates here 1, 24. We have the coordinates here. This is 2, 48. We can either count or use the formula, okay? So now this actually doesn't go up by 1 each time, so I'm going to use the formula here. So the slope is going to be, again, here's x1, y1, here's x2, y2, whoops, y2. Now you might ask, do I have to use these 2 points? Can I use this point instead? Absolutely, you can use that point instead, okay? You can use any points on the line. Okay, it doesn't matter which 2 points you pick, okay? Just as long as you pick the points that's on the line, then it's fine. Okay, so y2 is 48, y1 is 24, x2 is 2, x1 is 1, so you have 24 over 1. Okay, so 24. Okay, so that's part A. Part B says, what does the slope represent? So hint, the rate of change. Well, remember when we do this, this is the change of y values, which takes the unit of kilometers. So there we go, kilometers divided by, right, per. This is the change in x values, which takes the variable time. And the unit for time here is hours. So it's 24 kilometers per hour. So what does it represent? It represents David speed. Okay, that's his speed. Okay, that's his cycling speed. Okay, how fast he is cycling. Okay, so that's That's the speed. Okay. Part C, okay, so we can use the slope to determine the following here. It says how far David traveled in 1 3/4 of an hour. Well, we know the speed, so to find the distance, you can really just use the proportion, right? So because recall this is 24 kilometers per hour, and this is time in hours, so we're going to put it here, 1 3/4 of an hour, and how many kilometers, right? That's what you can do. Or if you know your formula from physics or science, that distance, right, how far, right? Distance is just the time times the velocity, right? D equals TV. So T is the time, V is the velocity or the speed in this case. So I mean, either way, you'll get the same result because when you solve this question, well, X, right, this is 1 hour, X is just equal to, if you cross multiply, 1 times X is just X, and you have 24 times 1 3/4, right? So again, you can see time is this and velocity is that, right? So it's, again, it gives you the same thing. This is going to be 24 times 7 out of 4, right? That's how you change mixed number to a fraction. 4 times 1 is 4, plus 3 is 7, so 1 3/4 is 7 out of 4. And you can multiply the fraction. You can write 24 as a fraction, 24 over 1. Then you can reduce this by dividing it by 4. Dividing 24 by 4, you get 6. 6 times 7 is 42 kilometers. Okay, so that's how far David can travel in 1 3/4 of an hour. Okay, what about the time it took David to travel 55 kilometers? Again, so you can use this formula or you can use this. I'll show you both. You can have the proportions, 24 kilometers per 1 hour is equal to, in this case, we want 55 kilometers traveled and x hours, right? So we can do your cross multiplication. You get 24x equals to 55 times 1, which is just 55. So x equals 55 over 24 hours. If you use the formula d equals tv, the distance is 55. The time, we don't know, but we know the speed is 24. So you can see to solve for t, you simply divide both sides by 24, and you get the same result, 55 over 24 hours. Now you can put that into calculator if you wish. In that case, you should get 55 over 24. You should get 2.29. But you're rounding here, right? I mean, this is not an exact value. So personally, I don't think we should round because then you are, this is a rounded number. This is not a rounded number. This is an exact value. Okay, so that is the lesson. Hopefully, you understand a bit more about what a slope is. Essentially, it's the change in the y divided by change in x, and it tells us how steep the line is. Okay, so recall, the bigger the slope, the steeper the line is. Okay, all right, there's some practice questions for you to do. Good luck.